The following content has been provided by RWTH Aachen University.
All right. Good morning, everybody. Thanks for joining us this morning. Today, we're going to continue our discussion of the ideation and prototyping phase of the DIA cycle. But before we do, let's have a quick review of what things are about. So last week, we talked about the DIA cycle. Anybody care to remind us real quick what those three phases are in the DIA cycle?
Design, implement, and analyze.
Exactly. Design, implement, and analyze. And we go around those each time, and things become hopefully more concrete, more precise. We also talked about the double diamond model. What were the two diamonds about? What was the double diamond model about?
Finding the right problem and finding the right solution.
Yeah, that's the important one. We usually focus on the second diamond a lot in the engineering sciences and practice. And the first one was important to know about, that you first identify which problem you're actually supposed to be solving, which one you should be solving before you dig in. And then I had these three questions, like when I shake you awake at 3 a.m. in the morning and ask you, okay, what are the first three questions that you ask yourself when you start a new HCI project, when you start to develop a new system that is supposed to be done in a user-centered fashion? What are those first three questions that you should be asking yourself?
It's like who the users are, what do they want, and what is the context of use.
Right, exactly. And then just as you said that, Elizabeth had her hand up as well. So thanks for offering to answer these. That's right. We talked about personas as well. And so personas are not persons. What are they? Can anybody give me a rough idea of what personas are?
There are like ways to classify our users. We could say we have the beginners, the average user, and then maybe the experts, the ones that really know the system that is currently in work.
Yeah, this is one dimension along which we can classify users. Although this, I have to say, I explained this at length last week, but I want to sort of qualify what I said there. Expertise isn't always the go-to way to classify users. Raskin makes a great case, for example, in his book on the humane interface, which is worth a read. That maybe expertise isn't the best way to classify things because people don't really become experts in that one dimension. So sometimes they're really good at the task, but not familiar with some functions of the software, but very familiar with other parts of the software. So expertise is actually a tricky beast. You're right, it's one way to classify users, but we need to be aware that expertise is a multi-dimensional quality. But personas were not so much there to use to classify users into groups. They had still another role to play. Yeah, there's another hand up there. Felix, go ahead. Felix, right now we can't see or hear you.
Oh yeah, sorry, but you should hear me now, right?
Yep.
Okay. Personas are non-real persons, but their properties rely on the results of the interviews.
Yes. So we build understanding, for example, through interviews, or maybe there's already a careful analysis of a certain demographic that we can find out through studies or whatever. And then we build hypothetical people, but they are realistic, right? And they're not elastic, so they don't, in our mind, that person doesn't just become whoever we would like it to be most, most convenient for the current design situation. Felix, by the way, after today's class, maybe you should take a look at your audio levels. You're coming in a little hot, a little distorted.
Okay.
But not a problem. We can still understand you. So brainstorming, next up. What are a few things, if you needed to explain to a friend, okay, the three sort of rules or something like that, that you would use for brainstorming, what are they? Some advice on how to do a good brainstorming session. Yes, Theo, go ahead.
I think the idea was just to have like kind of fun and to like throw ideas into it and not to discard any, like they may seem crazy, but in the end they may like be used. And like everyone should like take not too much time. It should be like restricted to 5 to 10 minutes.
Yeah, those are two good ones. So the first one that you said, having fun, yeah, that's a very alien concept to us, especially here in Germany, right? Having fun at work, that's weird. It is true that it's supposed to be a lighthearted exercise. It's a good one. With what that means is that people are allowed to have, weird ideas. And those weird ideas may not get picked in the end, but they may help others to come up with, by association, with a good one, right? So whether they become a final choice or not, they help move the process forward. So that's why we do this, what we call leapfrogging, right? And we go for quantity over quality, right? Lots of ideas are important, more than excellent ideas. So don't ponder for 2 minutes and then put out one idea. Rather throw out all the things that you could imagine. And then we talked about concept maps or mind maps for structuring that content afterwards, right? Where we have these concepts associated in this kind of a graph with the center being the topic of interest. That was the structuring. And then we have storyboards as the last part, which we talked about. These are these sequences of images that look like a comic book that illustrate a user in a certain scenario. Showing the problem situation and then the solution, and they're scripted a little bit like a movie script, right? Now today I want to start you guys off. I would like you all to find a pen or pencil and an empty sheet of paper, because we will start and continue the drawing exercise that we had to cut short last time. So in order to do that, I will start sharing my whiteboard, and as we do this, I would love you to keep doodling all the time as we go through this and as I talk about it, right? So the idea here is that you really want to keep drawing, right? So everybody knows that you might feel I can't draw, but I'll be honest to you, I'm not a great person to drawing either, not at all. But that's totally fine. We don't need to become artists here. This is not an arts lecture. This is a lecture in communication skills, right? These things that I'm teaching you today here in this short segment are going to be communication skills. So they help you communicate your ideas quickly by jotting them down on a piece of paper in a meeting for everybody to take a look at and understand what the idea is that we're talking about. So drawing people is like the worst, right? Oh my God, drawing people. We all feel like we got, or many of us feel like we got stuck at, the skills of a 5-year-old drawing stickmen, right? That's sort of, our typical drawing skill. And we can do better than that. Stickman is kind of not very expressive, but I'll teach you some very simple ones that are just as expressive or even more expressive than stickman. So Starman is the first one, and that's also the one that you saw maybe in the beginning of the video last time. Starman is easy to draw because you start by drawing a 5-point star, right? So that's probably something. Hey, it's going to be Christmas soon, so you should probably be familiar with a star. And that already looks kind of like a person, right? It's got a head and maybe it has eyes here and 2 arms. So we can do a little better by just changing the proportions here, making it a head like that, and then some longish arms maybe to add to that. Like there's one arm. Oops, come on. One arm, and there's one foot, a leg, the other leg, and there's the other arm. This is going to look horrible here on my pad. Excuse my drawing. This usually works better on a real whiteboard with paper or with paper and pencil. So you can draw a person like that really quickly, right? And what's good about this is that you can give it expressions, like a sad person or a happy person, right? So here's one guy that has his arms drooping down, and there's another one who has his arms like going up, and that can express, yeah, something worked out. I used the prototype suggested in this little Storyboard, and it was really great, right? So putting people into drawings is going to be important for us, almost crucial, because we're doing HCI, and there's human in that term. So we need to be able to draw humans and put people in our drawings and not just focus on the tech. Now, next thing you can do easily with Starman is have him push a button, right? So you just put one arm out to the side, and here he is pushing a button on, whatever it is, maybe a light switch on the wall, right? That's easy to do. As Bill was showing in his video, you can also replace the head with a little ball, right? And then just put arms and legs onto him. And look at that. That almost looks like a person now, right? That could pass for a person in a quick sketch. There are variations, more variations to Starman. Starman. There is, for example, Star Trek Man, of course. We all know the Star Trek logo, right? That's like this. And then you just put a head on that. This is good if you don't need arms to articulate some kind of action. If you just need lots of people in a drawing, this is a quick one, right, to draw. That's Star Trek Man. You can simplify that even more if you've got to be really quick. And I think Bill talked about like drawing an audience there. You can do, just lots of these, and then you put heads on those, and you got a group of people, right? That's really fast to draw, for example, an audience in a theater or something like this, or people queuing in line, for example. Now, or if you needed to do a family, there's a simple rule. The bigger you make the head in comparison to the torso, the younger the person looks, right? So a big head and a small body looks like a kid, whereas if you make a small head and you do a large body, it looks like an adult. So combining those, lets you, and of course size also makes a difference here, total size. This could be a little Star Trek Man family, so to say. Now, if you want to become fancy, and I would like you, while I talk, keep doodling, right? Keep drawing these things and just practicing your strokes on your paper there. If you want to be fancy, then you can also draw Architect Man. Architect Man is, when architects need to draw people, they do this cool shading thing, right? So they do something like this. That's a person, right? And they do two people like this. And then you tell them, and now draw a tree. And they'll be like, I can draw a tree. And they do this. And all of it looks kind of cool and sketched. And it's imprecise for a reason, right? And that could almost pass as somebody who can draw, right? But it's super easy. It's just scribbling, right? If you need to draw, business people, as of course, you can do your little person with a suit instead of being a normal dress, right? It looks like this. And so that's people, right? Now the next thing that is really tricky, I'm going to delete this, is hands. That is usually super scary, right? Drawing a hand. But a hand is really, mostly you needed to point at something or operate something. So it's easy to just say, okay, we got one finger that's operating something, and then we got a couple more fingers. Don't make it too many, that are doing other stuff, right? So that's your arm. And as you saw maybe in Bill's video, and I encourage you to really go back to Bill's video here, you can see you can draw a profile face of a person like this. That's really easy. Practice that a couple times, and you just put an eye in there. That's a very simple way to draw a person, and they kind of look a little bit different. They have different expressions, and if you want to express whether they're happy or sad, you just need to put a little mouth into them, and then they're like happy, neutral-ish, or really sad. It's also easy to combine these and have a person, the eye, the mouth, and maybe he's happy about what he's doing, kind of like smiling away inwardly, and then you got the arm going away there to just press a button, right? And that's all you really need. He got a little bit of a clunky arm there, but that's okay. I can do another one. There's always room for one more sketch. So you can do it like this, and then maybe go up and say that's the arm, that's the finger, that's the hand, and that kind of looks okay-ish, right? We now have a hand and an arm. So the other way to draw a hand is you can do more fingers, of course. You can say like there's one finger, and then we've got 2, 3, 4, 5. but you will often see that you actually don't need that kind of, you don't need that kind of detail. And you can take a look at your own hand if you wanted some idea for proportions and things like that. But we don't want to get too fancy with all of this, because it's really about, like, what are they doing? Are they pressing a button, or are they holding something, or are they raising up their hand or something like that? You can also, this is an important vocabulary to learn, right? So if I said, like, oh, I'm designing a system, it's a touchscreen interface, and it kind of looks like this. It's a smartphone as usual, right? So you can draw a smartphone screen and you can say there's something happening, but it becomes a completely different story if you then say, and there's a hand reaching in, and pressing a button there, right? There's somebody tapping on a key there. There's also great ways to zoom in on these kinds of things. It's fairly easy to draw a detailed finger tap simply by putting the nail of the finger in there. So that's easily drawn. Now we have a fingertip touching the surface, right? That's super easy to do as well. And so this is vocabulary, right? This is communication vocabulary essentially. And you can practice this with other things. Stuff that you will often need are things like an idea. And even though, the light bulb has already become obsolete for years now, it still sort of, permeates our culture as the logo for an idea. So it's pretty easy to draw a light bulb. You got that filament there with a little wiggle, and you got, the screw in end, and then it's off or it's on when you put a couple, dots around it. You can see I can't really draw in the classic sense of an artist, but I can communicate with these things. Other things that you need to maybe be drawing is things like files, and that's easier because we actually have logos for it. But take a close look at your desktop logos and see how they're done, and you can learn a couple things from those, because those icons are quite simplistic oftentimes. And this folded edge, this little fold in the corner here, or dog marks or ear marked, I think is the word, is a good document, right? If you want to say it's a text document, you put some lines in it, right? That's very quick to do. So these are all things that you can learn, and I really encourage you, take a look at that video of Bill Verplank's that we had in the presentation, and we have a full version of that video online as well if you want to see more about it. He is a living legend. He is actually the graphic designer who did many of the original icons on the Star user interface that we talked about, right? Remember that one from the 80s from Xerox PARC? He was the guy who came up with these visualizations. So he knows his stuff, and he's been a lecturer at Stanford University for many years. So he's an excellent person. He visited us in Aachen one day to give this workshop because I invited him over. And he's much better at this than I am. If you meet with Bill, you both go away from the meeting, you've got a list of bullet points on your piece of paper on your notepad, and he will have a drawing in his hand that captures the the essence of the meeting. It's really quite amazing. It's fun to watch people who are good at this doing it, and you can learn a lot of it. Okay, so with that in place, we're going to turn back to slides. Let me share the video here again. Share my screen. Oop. Here we go. Okay, now we're going to talk about paper prototypes. Paper prototypes are an interesting first prototype that you do after you've figured out your basic thing about the user, the task, the context, and so on, and you've maybe sketched a storyboard. When I start with an interface, I often start with just a paragraph of text, literally just telling a story of a user successfully using the product I have in mind. And then I take that story, that one paragraph, and add a little comic strip that shows the interaction in the very rough idea. That's often the very first prototypes. And once I've got that, then I move into something that focuses a little more on the UI and less on the context around, because that has now been established for the team. And then it might end up being a couple of screenshots, but still scribbled ones, not with the computer. The computer will actually stay out of these prototyping activities for a long time. Makes you maybe a lot, very uncomfortable, but you will be doing a lot of paper doodling and drawing in these prototyping sessions. So paper prototypes are a first prototype. They're very quick to do. They're very cheap. And that's important. They are quick. And that's why you need these drawing skills to be quick to do them. And they're cheap, right? It's a piece of paper, you draw on it, or you draw it on your tablet if you like. But either way, it's not as expensive as coding something for hours on end. They are rough sketches, paper and pencil sketches of the interface and central user interface dialogues. Now, I know that as a computer scientist, it's super tempting to move to drawing software and drawing tools quickly that are digital. It's okay to use what I use today, which was basically literally just my iPad and a pencil on that, like an analog piece of paper. But don't use a tool like Adobe Illustrator or something that lets you draw perfect squares because you think your squares need to be perfect. They don't. Don't use a computer to draw these. That's my recommendation. Really go with, buy yourself a big, nice, A3 size drawing paper, artist's paper. Buy yourself a block here from Listman downtown or something. And enjoy. Get some good pencils of different hardness. Get some markers like some Sharpies or Eddings of different thickness, and really go to town with this. It's fun to draw this way, and having good material makes it more enjoyable even. So try to stay away from the computer for a while, even though it is tempting. It's better to actually draw on paper and then just grab a quick snapshot of your paper drawing with a good camera that and a good software that brings out the contrast and so on, rather than drawing on the computer to start with. The advantages of paper prototypes are that they're not detailed, so their roughness, their coarse nature is actually an advantage, because it lets the designer and also the user that you're going to show this to, because that's why we do prototypes, but we want to share them with users in most cases. So the designer and the user will both focus on sort of, very coarse, high-level questions of the user interface. Like, they will be able to question, should this even be a menu-based interface, or should we have, just a couple icons instead? If you come with a very detailed drawing with lots of color and perfect lines and so on, there's lots of problems with it. And one problem is that people will then start focusing on the details immediately. Would say, I would like that button to be orange instead of red. And that's not what you are interested in at this point. You're interested in the big questions. Did I even get the right interface modality? Should this be, a voice interface instead, or should this be a gadget instead of a website, or an app instead of a desktop program? So these are the kinds of questions that you're after in the beginning. Did I even capture the process that I'm supposed to support with the software correctly? Can they make sense of my basic notions of the interface elements I put in there? I put in something like an order, because this is what ordering in a company. Do they even understand that this is supposed to be an order? This is the kind of questions that you want to ask at this point. Now, the problem with paper prototypes is, of course, you need intelligence behind it. Somebody needs to run the paper prototype, right? And that's going to be usually yourself, right, as the experimenter. So you take your paper prototype. It's a bunch of pages of sketched user interfaces, and you need to explain how the user what would happen, right? Because the paper prototype is not interactive. Obviously, it's just a stack of paper sheets. So if you're not around, a paper prototype can be hard to understand, because there's nobody who can drive the paper prototype to make it react to user input. The other problem, of course, with paper prototypes is drawing lots of screens is a lot of work, right? So if this gets out, into lots and lots and lots of screens that you need to do, this can take a long time. And that's where, for example, it starts making sense to maybe use templates to repeat things that you use often. And we'll get to that in just a second. And as I said, a storyboard can be your first paper prototype, right? A storyboard that is this comic that we talked about last time is a kind of paper prototype, right? It is only showing the interface or the system as part of a larger picture of the user and the environment. So, you have a person maybe at a desk sitting there, or at home, in bed, wherever they use the tool that you built, and your tool is there in the environment, but it's only part of the whole story. This zoom out in the beginning of the process really helps us understand that our system is going to be part of a larger collection of items and in running in a real environment. Okay, so let's look at these two types of paper prototypes in a little bit more detail. The first one is like a storyboard. So after you've done your storyboard that has this zoomed out notion of showing the user in context in its environment, and the UI only occasionally in zoomed in state, you can then sort of zoom in and say, I know I've got the basic story right. So now I'm going to sketch out each screen of the user interface like a snapshot on a page each, right? So you got basically a collection of screenshots that you sketched out. You can even put many of these on a single large piece of paper. So you got basically one screenshot, next screenshot, next screenshot, and then you put arrows between these and explain how we get from one to the next, right? User presses, this button, or maybe you draw a finger, a hand, as you just learned, showing that user presses, this button in the prototype, and that makes him move to the next frame. Also, it's a good idea to still label each frame and explain very roughly what it is, right? Give it a little bit of caption, like an image caption. Now, the problem with that is we now have a fairly fixed sequence to move through the prototype, right? We have a scenario playing out that is only one possible path through the UI. It's hard to convey many alternatives in this because you don't want this to become a highly complex graph, right, with lots of alternative paths. We'll get to that later on. So basically, the storyboard, like paper prototype, what I mean by this is it's still like a storyboard. We zoom in on the user interface, maybe the user's hand, and not the entire environment of the task anymore. The other option is a flipbook. In a flipbook, you really sketch every user interface snapshot on a separate page, and you have a loosely bound, flipbook that that flips over easily. And you use that in a way that you say the first page is the start page of your interface. Like, for example, if you develop a mobile app, the first page of your flipbook will be the start page. And you show that to the user and say, like, what is this? Do you understand what you're seeing? Tell me what you're seeing. Explain it to me, for me, please. And then, do an action. And the user says, okay, I'm going to press this button. I think it's a whatever. It's an accounting app or something. And then he presses a button for open new account. And then you go through your flipbook and you find the right page and you show that to him and say, okay, that's the new account page. Does it make sense to you? What do you take from it? Explain to me what you see. And what's the next button that you would, or interaction that you would do? And then he says, okay, I would maybe fill in my name here and then hit this, submit button or something, and so on, right? So you are driving the prototype in the flipbook, of course, and you're basically running it for the user. And this allows you to simulate the user interface for the participant in a study. So the participant is doing the interactions, and you are running the engine, so to say, behind the prototype. A couple of pictures here. These are actually mostly taken from actual classes, like DIS classes in the past, where students have done these. So these are totally within your reach to do in this class. This is an example of an interface that was built on a prototype, as you can see, that had still one of those phones that had a keyboard and a screen. And what they did is basically they drew all these panels out on a single piece of paper, and then they moved the smartphone screen here over each panel to say that's the current screen that you're looking at. It's kind of a nice way to do it, right? And you just need a very simple cardboard cutout to do that. Here's another example of a flipbook prototype. Also done by students in 2010. They prototyped an application for an iPad that was in the health area, allowing people to look at health data. And it was basically created from a cardboard box with insert sheets, so that allowed the user to actually hold the cardboard box like a tablet in their hand while they're testing the prototype. And the experimenters here, the students would then put each screenshot slide into the frame of this cardboard. And here's a fun story. The two students who did this, one was Ignacio Avellino, Nacho, and the other one was Kashyap Todi. They're both students in DIS1, and they both continue to do their PhDs in human-computer interactions. And they're now researchers. One is at the Aalto University in Finland, and the other one is at the University of Maryland in Baltimore. So this is how you can start out. But here's an example of the screens that Nacho and Kashyap drew there. For example, this could be the first screen showing the overview of the patient's information, his illness, which in this case is diarrhea, as you can see under the problems section here. And the buttons down there lead to more detailed information about this patient. And if you click, for example, on the history here, if the user says, I want to click history, then, Kashyap and Nacho would bring out the history timeline that they prepared on a separate slide, right? So now they say, this is what you see next, dear user. So showing the history of all his tests that he had over time. And then, the user might say, okay, so what happens if I touch the X-ray of button here? And again, they would basically then move to the next, find the next piece of paper, slide that into their little frame, and show that and say, like, yeah, that's the X-ray that you get. That is also stored in the app, right? And so on and so on. So you can see how Nacho and Kashyap were able to run their prototype with the user, explaining it to them. Maybe he's a doctor, and they can explain to him how the app would work for him if he used it in his daily work practice. Now, as I said, with lots of screens, this can become tedious, right? You already saw that lots of stuff here were repeating themselves, were repeating across these things. For example, it's always said Max Mustermann at the top there. And you may get, bored of drawing the same screen again and again with just minor changes. And there's a solution for that. And you still don't need to go to your computer for it, because what we use next are post-it prototypes. A post-it prototype is a more interactive version of a basic paper prototype. What it does is it uses post-it notes, sometimes multiple layers of them actually, to simulate things like dialogues popping up and being closed again, or menus being opened and commands selected, or windows opening and closing, and so on and so on. So you can simulate all of this by drawing these elements onto individual post-it notes and then just sticking these onto your paper background and removing them again. This is a huge advantage because it lets you show much more detailed interactions without having to draw entire screens for every single little change in the interface. The other advantage, and that's maybe less obvious, the first one is obvious, but the other one that's less obvious is it is also a very quick way to create new, to change your interface. Sometimes in the middle of a user study, you discover, oh my God, I totally messed this part up, or everybody's asking about this subscreen and I didn't prepare it as a paper screen. You just draw it, or you just draw, the window that's missing, or you change, maybe the dialogue was unclear, the buttons were unclear. You just take it out and you draw it new. It takes 30 seconds to doodle it in fresh onto a piece of Post-it, and you fixed your interface, right? You improved your UI. So it's very quick to change. Again, if you need to do lots of these, for example, if you have lots of dialog boxes in your app, then it can be worth preparing templates even for those. So you could have a stack of Post-it notes that are all dialog boxes with a little bit of an OK cancel or buttons prepared, and then you just need to fill in the details on each of these to just be even quicker, right? But that's already pretty advanced. Usually you don't need to go that far. It's enough to just have empty Post-it notes and you cut them to size with scissors if you need small things, and then you fill in the details. The other tip that I want to give, and that's always a good idea, especially these days where recording a video is not a big deal at all, right? Tape your session. So capture a video of your user session when you use your post-it prototype with the user for analyzing it later, because you might be changing things in the heat of the moment, and it's hard to keep track of your changes and make notes and listen to the user all at the same time and be present in the study. So tape it, and then later on you can review it and make notes on carefully what you changed and why you changed it, what the feedback was. We got, again, this may be a little abstract, so we got lots of examples here. Here's some radio buttons or checkboxes, right? You see here's range name is chosen currently to be prototype range, but this could be changed if the user says, I want a different range. You just remove that sticky and put another one down, right? Or if, for example, the user wants to change the default width to something else, they could do that, and they could basically choose a different width by clicking that other button. And you see even the radio button with the little dot here has been selected with a post-it. Also, the selected checkbox is just a sticky, right? So beneath that selected checkbox is obviously an unselected checkbox, and you can just move the checkmark sticky with, of course, the checkbox around it, to say which things are selected and which ones are not. In the case of checkboxes, you might need a couple because checkboxes can be selected multiple at a time. In the case of the radio button, you really only need one that you move up and down the selections. Here's a little video that will maybe show this in a little bit more detail. Let me play that real quick. Yeah, so here you see, we've got this is a sticky, this is a sticky. These are stickies that you can remove and just move somewhere else. You can take that off and just do a different one, maybe with a different number on it, and you can remove these quickly and put them back. So it's all very, very fast to change. Moving radio buttons around, as you can see here, it's super easy, right? So that's a great way to simulate a user interface interaction in response to the user's input. Now, we can do much more than that. And this one might be obvious, but the next ones maybe not. So here's, for example, an expandable dialog box. You've got an arrow dialog that's displaying. And if the user wants to see the details by clicking on the detail box here, you just literally fold out that piece of paper. Did you see that? It was actually a folded over piece of paper, and the details were stuck right beneath it. So I didn't even need a separate post-it for it. I had it just folded away to display by flipping it out if the user asks for it. That's easy to do in terms of expansion. A little trickier are things like the typical path and folder hierarchy navigator that you have in your Windows desktop or your Mac folder, Mac Finder, and so on. So in the first step here, we got a couple of folders here, the users folder, and then as has the desktop. On the desktop, there's pictures, music, and games. And if the user then says, I would like to open the music folder, so he taps on the plus button in front of the music icon, then what you do is you literally replace the closed music folder by a new post-it that goes on top and covers everything else, and that expands now the music folder a little bit more. And then you need the rest of that as a fresh sort of add-on that now gets moved down a little bit further, right? So that's cut off. So that is a great way to do these kind of fold in and fold out operations. You can also do this, for example, to show a drop-down menu, right? Somebody clicks on a menu, you put down the menu bar, and then he selects one, and then you just remove it again, and the menu is back. Graying out controls is something we often need, right? This is taken from a wonderful book called Paper Prototyping by Carolyn Snyder, in which she shows lots of examples of doing good paper prototypes. So, for example, if you wanted to gray out certain functions, you could just say, let's say the user hasn't currently opened any kind of document, then you might, gray out the save and print menu items, for example, and then you just basically put stickies over the black words, and those are written in gray to indicate that they are currently not selectable. Here's another one. These students actually had to design a user interface for a copy machine, and they decided to make it so that the user could actually manipulate how the copy is cropped for the, how the original is cropped for the copy by handling these two pieces of cardboard frame. So they could literally like stretch these things in both directions and thereby indicate how much of the image the user would like to see cropped in the copy. They use actually some separate pieces of cardboard here to simulate the crop marks, and the user can move these crop marks around during the prototype test. Okay, so that's paper prototypes and Post-it prototypes. Understand that paper prototypes can be just an extension of your storyboard that focuses a little bit on your UI, or they can be that Flipbook that you basically go through page by page and you drive it, or they can be then made more interactive by using Post-it notes to simulate individual parts. Now we're moving into software prototypes. And software prototypes are sort of a medium fidelity prototype. They are a kind of prototype that is a bit more detailed and more precise and more interactive than your paper prototype. But the important thing is, again, I need to keep pushing you guys away from your computers in this class. It's really hard, right? But you want to do this only after you've done some initial paper prototyping. When you have figured out the rough idea of your UI, you're not making any major big mistakes in your UI anymore. Then you move to software prototypes to increase the fidelity, increase the quality and the precision of your UI prototyping. They are usually a mock-up, a model or an illusion of some aspects of the UI. You don't usually build all of your final UI in this prototype. I will talk about how we limit prototypes on the next slide. A very simple example to do this is what I call the PowerPoint prototype, where you simply doodle your user interface with drawing tools, or maybe even screenshots that you take from paper drawings, and you put them into a PowerPoint presentation, and then you add some buttons to your PowerPoint presentation that let you navigate through these screenshots. That lets you maybe even be non-linear, right? So you can jump from like page 1 to page 3 to page 2, or you just put your screenshots into a PowerPoint presentation slide by slide, and it's just a click through. That's possible as well. Now, they're called software prototypes, but again, this doesn't mean that you need to be coding a lot. It just means we are now running the prototype inside the computer, usually using some kind of prototyping app. This can be a very simple tool like PowerPoint, or even a drawing application like Photoshop, or it can be something more geared towards prototyping. We'll talk about a couple tools later. What's nice about having prototypes digital in this form is that they are actually a little bit more engaging for the user to try, because the user can play around with these prototypes without the designer having to be there and exchanging paper sheets inside a cardboard frame, right? So they can be self-driven. They're also better to distribute than a cardboard prototype if you want to send them out to users, obviously. All right, let's continue with how we can limit software prototypes or prototypes in general. Now, there's two fundamental ways in which you can limit a prototype. Option one is to say, I'm going to make a lot of the UI or all of the UI, but I'm not going to implement the layers beneath that. And we call that a horizontal prototype. So it's a prototype that basically has the surface of your application, the UI, but it doesn't have any of the code behind it to do the things that the UI is suggesting. And that sounds like it's impossible, but it's actually very easy. So for example, if the user says, create a new database record with a name and so on, you just have a ready-made database record that has some sample name filled in, and you show that in your user interface, rather than actually having a database going through a collection of names or something like that. So we're simulating everything. Nothing really works, right? If you say print, then in this prototype, then it will say printing, and in the demo, if you try this with the user, they would then have, the experimenter would then maybe hand them a sheet of a sample printout of the application, how it would look. Right? The other option is obviously a vertical prototype, which means I have printing and saving and creating new records and deleting records and all these kinds of things in there, searching, and I don't implement all of these. I may focus on just the creating new records functionality, maybe because that's very central to the tool, or maybe it's the first one that users will encounter. And so this allows you to just implement a few functions in detail with actual working code beneath it, so they actually do what they're promising. And that lets you test some, the general design of your application by example of a sample function in your application, right? Your application is a collection of features or functions for the user, what it can do, and you just implement one or two of those, and that helps the user to see how you're imagining the rest of the app to work too. And what we mostly do is actually a combination of these, which means we only go into, we only do a layer of the user interface, but we only do it in a particular area too. What that means is if you want to, for example, say, I want not to show the entire user interface because that's too much stuff. My paper prototype or my software prototype won't show everything in the UI. I won't have all the menus dished out, fleshed out. And I don't have them implemented either. So I have neither really. Then you end up with that little square there in the middle, right? Which is the combination of vertical and horizontal limiting. And that is what we would call a scenario. So it basically takes the user on a very clear path through a very small part of your application. And that is a fairly common choice, right? Limiting both the breadth of the UI, but also limiting the implementation depth of the prototype. So a couple examples of software prototypes. The simplest software prototype, and I'm wondering, Ollie, maybe we should call these digital prototypes, because at this point, it's not really much about software, really. Let's consider that maybe for next time. The simplest version is screenshots, right? You just have Photoshop or PowerPoint, you draw a couple screens, you take the UI from your storyboard, you put each of these on a separate slide or layer in Photoshop, and you then step through these, right? In sequence, in the simplest case, for a scenario where there's no options for the user to do one or the other thing, they can basically just say, okay, what would typically happen next when the user does a likely action? And that's a very thin horizontal prototype, right? It has no functionality beneath it at all, but it's already easier to change than analog pencil and paper or posted prototypes because of the digital nature of it. So if there's a change that you need to do, you can easily use Photoshop layers, for example, to have a dialog box template, and then if that needs to be changed somehow, because maybe you want to do this in another language with another user, you can change that much easier than having to go through lots of paper drawings. The other thing that software prototypes allow you to do, even these simple screenshots, is that they allow you to have more detail in the visual level than the paper prototypes. And also they allow you to have a higher quality of rendering. This can be dangerous, and I'll talk about why this can be dangerous in just a few minutes, but it's possible, right? You can be higher quality in terms of the appearance. And sometimes this design that you do in this prototype screenshot, especially if you're working already with the artist or the designer who's doing the actual final user interface graphics, then this can become part of the actual UI, right? These designs. And I'll show you an example in a project that I did where that happened. This is especially useful for non-standard GUIs, because, I mean, it doesn't make sense to carefully recraft a standard macOS dialog box in PowerPoint, with drawings and stuff. You will just take a screenshot from the actual dialog box if you really want to be, use that actual interface object. But if you have a non-standard GUI, for example, for an interactive exhibit in a museum, where you don't want to show, standard user interface controls, then this is a useful approach. And just like with the digital version of any prototype that turns into software, it's of course much easier to distribute electronically and pass on and have users test it. So one example, let's say we've been asked to design a an in-store digital shopping opportunity. And this was a completely harebrained idea many years ago that a colleague suggested as an example for these prototypes. Actually, when you walk into a Rewe these days, you get this little hand scanner, right, that you can use to scan your products as you put them into your cart, and you actually build your own bill. So this has actually become reality, sort of, 10 years later or so. But here's what a prototype about this interaction. Let's say this is in like a Toys R Us store, right, in a toy store. What this could look like. So the UI, what we're seeing here is a prototype of the user interface on the right-hand side. And on the left-hand side, we see, as part of this user interface prototype, which I'm running inside, basically just as a series of slides here right now, I've put a little bit of a hint on what's happening externally to the final system. So the system itself could maybe be a little tablet that is mounted on, on a rack in the store. It's a little point of sale kiosk, right, that I can walk up to and use. And next to it is maybe, let's say, this stroller, right, with a barcode attached to it. And so the system here says, okay, so find the item that you want in the catalog and then scan the barcode next to it, right? And so we see this right-hand side here is the simulated user interface. And now, how do I simulate the user scanning a barcode? Well, I use a little bit of a graphic and move it in and out in Keynote and say, okay, user has now scanned the barcode, right? That's all I needed to do. This was a simple animation inside Keynote or PowerPoint to illustrate, to show that interaction. Next, user might decide to actually use blue as the color of the stroller instead of green. So again, I can bring in a little hand that taps the blue button, and when it is removed, the cross moves from green to blue, right? These are all simple PowerPoint Keynote animations. And then the user might hit place the order down here, and then the information at the top when he hits the order button changes, and it says, well, to actually get your items, just bring your printout to the front counter, right? So this is sort of the idea that you scan these things from the catalog, you build up your, what you want to buy, your digital shopping cart, and then you go to the cashier, and the warehouse collects your order, kind of like it works at IKEA sometimes, actually, and they collect everything for you to pack and take away in your car or on the bus or whatever. And you see here a little icon of a printer is simulating, the printout, right? So that was a simple linear click-through prototype using Keynote, right? There was no options for me to take as a user exploring this prototype. I could only use one path. I can do better than that. I can have more than one path. But for now, this was a very simple one. Now, there are some problems that I mentioned with screenshot prototypes. The first one is, even if I have, with what you saw right now, it doesn't really let me interact with the UI. It's more like a click-through, right? I haven't felt like I'm really operating that thing. I'm just basically watching a slideshow, right? And that we're going to address in the next extension of these screenshot prototypes, with non-linear ones. But there's another danger, and that is a fundamental one that I want you to pay close attention to. When you do a screenshot prototype, it's tempting to use and make something that looks very polished, because you can use snapshots from the actual user interface, maybe user interface components. You can use the exact button that macOS would display, for example. And this will lead away from the coarse feedback and the rough feedback about the overall interaction, and will lead towards fine, detailed feedback about the nature of each button and widget that you use. And that's okay at the very end of your process, but you don't want to get into these little bit detailed discussions too early, right? Because you don't want to limit the feedback that users are giving you. The other danger is you show a very polished screenshot prototype to a manager, and they may not understand that this screenshot is actually not working. And it's not because they're stupid. It's because exactly what we talked about in DIS1 earlier. For the user, the system is the UI, right? A non-technical, non-developer user, for them, Word is what they see in front of them when they use Word. So if they see something that looks like a shopping app that I just showed you, they will think, well, that the app is done, right? It's there, I can see it. And they may not understand that this is in reality just a bunch of screenshots with no code behind it whatsoever. And 99% of the implementation still needs to be done. So that's a dangerous thing that you can fall into, especially when you're interacting with clients or upper management, right? And finally, the screenshot prototypes that we're talking about here are obviously missing the physical aspects of devices. I didn't really get the feel of holding this in-store shopping tablet in my hand. I just had a screen to click on or to click through, actually. And we'll also address that with hardware prototypes later today. So first, what can I do to screenshot prototypes to make them a little bit more dynamic? Well, I can script simulations. I can basically have interactions happening. You saw already some examples of that, like the scanner moving in and out. So rather than telling the user, okay, now imagine you scan the item, you can at least show a little bit of an artificial hand scanning the barcode to show that, right? It makes it also easier to understand what's going on if you happen to not be around when somebody uses your prototype. So you might be able to more easily share it. You can use tools like PowerPoint, Keynote, and their options to link from one slide to the next slide, or use the many various effects that they allow you to do with animations to do that. You can use Photoshop and its layers, or another drawing application, of course. The layer functionality often lets you blend in and out certain parts of the image in response to user input that the user tells you about what they want to do. You can have transitioning happening by a simple input, like the user clicking on the button, but you can also use timing, right? You could say, for example, that printout that we just saw could just basically be a little bit of a printer appears, and then after 10 seconds, the printer disappears because that means the printout is done, right? Or you can use animation, as I said, moving things around. We already saw that with the slide in and out here in the example. So this can make prototypes a little deeper, right? They start having a tiny little bit of vertical depth because they now react to, for example, clicks on different objects on the screen, rather than just being a next slide, next slide, next slide, no matter what I do. And we often still make click-through prototypes because they are great for pitching an idea, right? If you know the story you want to tell with your prototype, then it's enough to have a click-through where you just show that one walk through the UI to your audience, because you don't need any deviations from it because you're telling the story. So obviously, looks good, looks real. It's especially useful, as I said, for non-standard user interfaces. And we still don't have to start coding. Now, I know you're very comfortable coding, all of you guys, but we're trying to hold back on that for the reasons that I explained earlier. Coding hours are very expensive, and we don't want to code something where we don't even know whether that functionality is the right one to build. Remember the first diamond, right? We're still exploring exactly what problem we're trying to solve. The disadvantage, of course, is when you're not following your script, then if you have a linear prototype with this without any cross references, then and let's say you're presenting your prototype, and at step 3, somebody in the audience says, some user says, hey, but what happens if I press this other button here? And then you got to say, well, sorry, I don't have that scripted right now. I can't show you, right? So that's why nonlinear prototypes are the next step up from these click-through prototypes. I'll show you an example, I thought, of these nonlinear prototypes. Actually, I'll show you 2 examples. The first one is from a project that I did many years ago. It's an interactive exhibit that lets users conduct an orchestra. It's running in the House of Music in Vienna, a museum, and it's been running there for many years. Millions of visitors to the museum have used it and enjoyed conducting the orchestra. And when we built this interface, we had to show an early version of the interaction that we were imagining to the client, to the museum. Now, in this case, we worked with a graphic designer who, at the same time as we were hashing out the interface logic, he was basically already going ahead and creating the visuals for this thing. So this will look quite polished, don't be surprised. But what we did together with the graphic artist is that we used different layers inside Photoshop to simulate, for example, the highlighting of different menu options or the moving to different screens. And because the graphic artist did such a great job in his artwork, this example that you're going to see here actually also in the end turned out to use, the same assets as we used in our final graphical system. So we ended up using these prototype drawings and put them as graphics into our final system. But that's not normal, right? That is something that happened in this particular case. So here we are inside Photoshop, and we first look at the window menu, and we activate the layer menu, right? And the layer menu then lets us look at all the layers that are available. And you can see here, these are named so that we can make sense of them. This is, for example, the foreground layer that contains some basic explanations. And then we can turn on all these other ones, which are the individual buttons that the user can select to pick a piece they want to conduct. But these buttons look kind of boring. Each of these has a background. But normally you don't see all these highlighted in this way because you only want to see the currently selected music piece like this. So now we only have the Radetzky March selected. And now we've moved the selection to the Blue Danube, or now we've moved it to A Little Night Music. So that's how the user would select things, and that's how you can simulate that. With layer comps, we can actually build some even more advanced things. See here now, I don't need to highlight and select and deselect individual layers. I basically just move through combinations of layers. That's what layer comps are in Photoshop, to show how the user moves up and down the selection. They do this actually by waving a baton up and down to step through these different layers. And that lets them sort of interact and show each layer. So this is a pretty useful way to illustrate how a user interface might look by simply having doing some magic with Photoshop and use these layer functionalities of Photoshop to step through things. Okay, so you can actually even do a Wizard of Oz setup with this. You could even say, hey, one person could have, this could be displayed at a big screen, and the user could have a cardboard baton in their hand, move it up and down. And even if we don't have any of the technology working, somebody behind the screen could simulate, the highlight going up and down by quickly clicking on these layer comps here, as the user in the study is moving their wand, their baton, the conducting baton up and down in the air to point at these different items. Okay, so nonlinear software prototypes like the one that you just saw, are basically ways to actually enable you to go through different parts in your prototype, not just a click-through. So they have definitely more horizontal and vertical depth than just a single scenario that you walk through. The sequence of actions is no longer predefined, and essentially the user can decide what to do next, and they can even do it themselves, right? You can actually give these kinds of prototypes to users and let them explore it. I want to show you an example here, which is one that I built myself a couple of years ago when we were asked, because we are also responsible for the website of the computer science department at our lab. And so we were asked to redesign the website. And so before we went in and built it all, I created this very simple Keynote prototype, PowerPoint prototype, if you like, that actually just used Keynote's functionality to jump to different slides by clicking on certain buttons. As you can see here, this is not actually there, right? This is just inside the screenshot here. Inside Keynote, you can open up, you can create this button that will take you to a different slide if somebody clicks on that area. And that's what I used to build this prototype. So let's take a look at how this works. So imagine yourself, you're now sort of, you're all my colleagues who want to see the new computer science website before it's actually there. and I'm going to give you a little walkthrough. So here's the clickable prototype of the computer science department's website. It uses links in Keynote to jump to these other slides. And as you can see, the main navigation bar here is actually clickable. So I can now click on Studium and it will open up, right? Or I can actually click on Wirtschaft, something else, and that will open up. And I can actually step through these individual things. Sorry, I didn't implement the Wirtschaft one, I think. So you can see here's Aktuelles or Studieren bei uns, or you can go back to this first one, and you can basically step through all of these different things and see how they move back and forth, right? And each of these menus is just done by having individual slides that we step through, right? So and here's, for example, what's under Forschung. You can see that. Here's the Wirtschafts part, and here's the Fachgruppe part. Ollie, we need to fix this because this is currently actually not a clickable prototype. It seems it got turned into a series of slides. It should be an interactive one that actually reacts to the clicks as we step through. I don't think it's currently doing that. So when you use these kinds of prototypes, you can basically react to the audience saying, hey, what's behind the Wirtschaft button? Can you show me that? And you say, yeah, sure, here it is, right? So that's very different than having to talk people through your interface in only one possible order. Now, what I used for this was Keynote, and that's very primitive to do. There are lots of tools out there that have begun to become much more, how should I say this, much more geared towards actually building prototypes. And most of these tools, except for maybe Balsamiq, have only evolved really in the last couple of years. So there's a great new set of tools out there. Prototype, these are all toolkits to do what's called wireframing. Wireframing means basically you do what we just saw in this PowerPoint version there of the Fachgruppen website. You sketch the UI, you do it digitally at this point, but you don't flesh out exactly how it looks. It still looks like a sketched version, but it is digital. And that's what a wireframe is, like a wireframe of a 3D object that you model. A tool that's been around for a long time is called Balsamiq, and it is a very simple tool to build exactly these wireframing screenshot prototypes. Not much more though. For example, it wouldn't let you scroll through a long list by doing scroll motions on a small screen. Adobe XD is a little bit late to the game, but has become a pretty good prototyping tool that is more powerful than what Balsamiq offers, but also more complex to use, obviously. And Sketch is a very interesting one. That's the one that, for example, even the Apple team internally uses to do the prototypes for their own software. All of these are interesting to look at. For all of these, you can get a free version either for permanent use or at least for a test sequence. And so if you want to learn more about these particular software tools, then there is a lecture in DIS2 next semester about that topic, in which we go over these and the pros and cons of each and how they basically work. We also have provided here a link to the interactiondesign.org website, which happens to have a little article on freely available test versions or home use versions or educational use versions of a variety of these tools. So those two resources are going to be especially useful for you. Now, sometimes you need to build interfaces that are not standard GUI, right? That are not standard buttons and menus and scroll bars and so on. And then you may need something like an animation app. Animation apps use a timeline metaphor, and they're very good if you need to build very intricate animations as part of your user interface. They can actually be even more powerful when you extend them with scripting options. Like, for example, you can basically then use something like JavaScript or something to script these things. Some of these animation tools have scripting languages built in that are a bit clumsy by computer science standards, but it's gotten better in recent years. What you can often do with these things, but because these are built to create basically interactive animated experiences, like games, for example, educational games or stuff like this, and they often also let you integrate non-standard hardware and other features of the operating system into your presentation. So they may offer you actually a way to plug in, I don't know, an Arduino board and a sensor to pick up the sensor data and thereby detect whether somebody is tapping a light sensitive sensor or something. Or opening the door of their fridge and then react to that, right? If you're building a prototype for a smart fridge. Adobe Animate is a recent tool that allows you to do that, and it actually lets you then export your final prototype into HTML5 so you can get that animation online and share with others. And sometimes these things, again, can even become the final product. But large designs in these animation apps become hard to manage because they're not really made for these highly branching, complex alternative options scenarios that you have in complex applications. Again, more about these applications in designing interactive systems too. In general, as you may know, DIS1 is trying to get the right mindset and knowledge about the human and psychology and the design process in general into your heads. And then what we do in DIS2 is that this is where you will learn the technical tools, which will be much closer to computer science, actually, the engineering tools that we use to build and prototype all these things. So DIS2 will be much more about widget toolkits and graphical user interface toolkits, etc. Of course, since so many things are made for the web these days, you can use the web also as a prototyping tool. You can use HTML and JavaScript. It's a natural choice. Of course, if your final product is also supposed to be on the web, right? Then why would you use something else? Since the web has become so ubiquitous for us to use online, there's also tons of tools out there that allow you to build your prototypes using web technologies. Some advantages of that is, apart from the many tools out there, that you typically do things in a clear text format, right? You're doing stuff in HTML, so it's pretty readable and easy to go back to later on, even if the project has been wrapped up and you just need to look at the source code again. Might be easier than some custom animation tools, a binary format in which something was stored that you can no longer access because the software is no longer around. In theory, at least, you can look at these interactive prototypes using any browser on and over the internet. Now, the reality of browsers, so things are not quite that easy, but HTML5 is reasonably standardized these days, so you got a good chance, if you don't go too crazy, to create a prototype that runs across the main browsers at least. And there are websites to make sure that you don't break these compatibility things. If you want to know more about this, I recommend the Web Technologies lecture by my colleague Ulrich Schröder, who goes, of course, into much more detail on all of these things that you need to build software that runs on the web. One of the problems that you easily run into on the web is, though, that everybody can set their browser's preferred font size to whatever they like. So it's really hard to communicate an exact and precise look and feel in a browser interface. They could just resize the browser to be narrower or look at it on a wider screen. And HTML was never meant to be a fixed exact layout, like visually, this pixel goes here, right? That's not what HTML was about. It's a markup language that structures things logically. And we've fought against that with CSS and cascading style sheets and whatnot. And you can lay out things fairly reliably, but in the end, there's always an option for a user to configure their browser so that it looks differently. So if you need to communicate a pixel perfect rendition, web tools are not the way to go. Maybe explain Electron and Cappuccino here real brief. Electron you've probably heard about. It's a way to package the same code, basically HTML, JavaScript stuff into native applications for Windows, Mac OS, and other desktops. So you basically download an entire browser, you just don't see it, right? And then everything runs inside that browser engine. And Cappuccino is a framework that makes it really easy to create advanced web apps. You write a couple lines of code, and then you got a full app with undo, redo, table views, drag and drop, modern UIs, everything you might expect on the desktop. Okay, so for this, we got another demo for you, which Ollie is eager to present at this point. And this will be a little demonstration of how we can prototype interaction with HTML5 and JavaScript, right? Because HTML5 and JavaScript lets you prototype UIs quite nicely. You can even create a simple drag and drop operation and basically use your web browser as the IDE at this level, at this stage of prototyping. So let's look at Ollie's demo here for a sec.
Yep. So thank you. Okay, now visible. Just let me quickly share my screen for a moment. And this. So now you should be able to see a huge black window with some code, and on the right side you see my web browser with the application. And this is what I prepared at the moment. As Jan said, I will do a drag and drop application here, and yeah, in this case we just created an interface for a shopping app where we have a list of vegetables here in this case, and we want to purchase them and put them into the bag. And as you can see at the moment, I can move those objects currently, but if I release my mouse button, nothing is happening. And we try to fix this. So we want to purchase those items by placing them in the bag. So what you see here in HTML is pretty basic. I have here my my orange rectangle, which is an HTML div here called ID, here called item list with the ID item list. That is a bit important. We have the shopping bag. You can see the div for that here, which has the ID bag. And within the item list, we have 3 images with, yeah, for each of those vegetables, one's for the carrot, one's for broccoli, and one's with pumpkin. And just quickly to show you the rest of the HTML, this is here just a lot of layouting code, which is simply putting some margins, the positions, the width, and the weight. This is no huge effort to do so, and you can quickly come to this when you start with HTML. So yeah, let's focus on the interaction here. And here we have a short script environment we will have a look at later. So coming to implementing the drag and drop feature here for HTML. So the first thing we should do is, yeah, having those images here of the carrot and so on, making them really draggable. And therefore, we need to make some changes here in the code for each of those image tags. For this, I will use a multi-cursor, but because I have to do everything for each of those images, but I hope this is not too confusing. So the first thing we have to say is, yeah, we want to make those things draggable. And this is simply a Boolean thing. And this way, HTML knows, okay, we want to do drag operations with those items. And how it is with yeah, such interactive things, we also have to implement some listeners. And in this case, we want to get a listener of yeah, what happens when we start dragging. So therefore, we have here the option to write the method onDragStart. And in this case, we can reference to a JavaScript function we have in our scripts environment. I will show you in a minute. And so then we have a function which is called drag. And this function just got the variable event. And what this does is pretty simple. When you look here at the code, is we have this event. And what we do is we add the information of the object we are moving currently. So here we get the ID of the object we are moving on the right, and we save this information with the key moved object, and that's it. Then, on the other hand, we have to define what happens when we release the mouse button. So how do we drop the item to the back? And therefore, we go here to the div with the back. And also here have to write some code. First of all, we have to make the back aware, more or less, that we can drop items on it. So we say if we drag over this back, then we want to do some actions. We want to allow this. And again, we have a JavaScript function for this, which is in our case the allow drop function, and it also just got the event with it. And again, jumping up here to this function, you see the only thing we do is more or less saying don't do what you always do. And because usually those items are not, don't allow just dropping those items there. And therefore, we just have to say, okay, don't behave as usually. And finally, after we said, our back is allowed to do drop operations, we just have to define what happens if we release the mouse buttons and the drop actually happens. So we have to tell the code, we have to define what happens then. And therefore, we just have another listener, which is the onDrop. And again, we're referring to a JavaScript function in our environment, which is called drop. And we pass the event, and here the most complex thing is happening. And this is just saying, okay, first of all, we check, is this the correct item where drop operations are allowed? In our case, we have a certain look on the back, and yes, if it is the back we drop items to, we again say HTML to prevent the default behavior, because in this case, usually the browser would open a link. And then we gather the data we have stored before in the with the moved object key. And what we do is getting this HTML object and add this to the current target, which is in our case the back. And with this code, hopefully when we now refresh here the browser, I should be able to move the caret and place it on the back and release my mouse, and the caret stays where it is. And we can do the same with the broccoli and the pumpkin. The only problem is, well, Halloween is over, I don't need a pumpkin anymore, and I want to put that back, but this does not work anymore. So we have to do the same we have done for the back, also for the box here with the available items. And therefore, we can simply take the listeners we have defined for the back and put them to the div with the item list, so for this orange block here. And if we do so, if you remember, we have also defined the item list as an acceptable target. Then with refreshing the browser, I can put the items down to the back and also again to the item list. So this was really not a lot of code, and this is very easy to do. So don't be afraid using HTML and so on for creating the first interactive prototypes. Switching views and so on is also very easy with different HTML files. And so you can really quickly create your first prototypes using this technology. Yeah, so I think that's for my side. And you can continue with the lecture then.
Awesome. Thank you, Ollie. Okay. Let me share the screen. Here we go. Okay. So so that's how you can do this. And I think, Ollie, you were using a Bravo, right? Can you talk about the tool you were using to edit the code there? That was just basically a plain old text editor, right? Nothing special.
Yeah, it was just Atom.
Ah, okay. Mm-hmm. Good. So it's a tool that will be very feel very sort of comfortable to use, right? Because it's stuff that we are very aware of and that you guys use every day anyway. as long as you keep the problems of web prototypes in mind, that they can quickly become unwieldy if you are dealing with different browser environments, it's a great environment, not just for building something that is meant to become a website or a web thing in the end, but even for non-standard user interfaces, it can be a good choice. And if you are in a position to control the device and the browser settings of where this is going to get used in the study, for example, because you don't plan to send it out to people who use it unsupervised, but you only plan to use it in studies and focus group settings and whatnot, where you are there and you are giving out the devices with your settings, then you can actually have pixel perfect rendering exactly how you want it, right? Because you can control the environment enough to make it look exactly the way that you intended it to. And then it makes perfect sense even for, if you're building an app, you can use a web prototype to simulate that app in a very rough sketch. And remember that we have two kind of ways or two levels of fidelity, right? We've got visual fidelity and we have interactive fidelity, if you like. You can make something that looks very polished, but is completely dumb, right? Because it's just a pixel, it's just a bunch of pixels on a screenshot. Or you can make something that is very rough, like sketched, looks like a pencil sketching digitally, but is actually highly interactive and reacts to input and drags and drops and whatnot, right? So both of these are adjustable for you. And I would recommend to try to balance the two. People tend to think the more precise a visual rendering is, that also, the more functionality it will have. A rough paper, like, a sketch that looks like it wasn't done on paper, is not something that people would likely expect to be interactive. Whereas if they see a button in all its glory, rendered like with the operating system, they might be more tempted to think that this would actually work. So one other thing I wanted to mention in drawing before we move on to other tools here. There is a wonderful book out there that is called Understanding Comics. Understanding Comics is a book by Scott Mcleod, who's an excellent comic artist and designer and graphic designer. And he wrote a book that explains how comics work. What is the visual language of comics? And this book is so amazing because it is actually itself a comic. So it's really worth taking a look at that book because he shares with you the tricks of the trade. Like, how do panels work? How do people naturally follow from one panel to the next? What are the, for example, also these questions of visual precision in a comic sketch? This is something he talks about at length. So take a look at this book. It's a hilarious read. It's very enjoyable. It's great for your Christmas last minute. I have another book that I would like to have for Christmas list. Understanding Comics by Scott Mcleod. I recommend that. Okay, now, and maybe Ollie, we can add a note about this in the slides for next time, so we have a screenshot of the book. But there are other tools out there to let you do what we just did with web technologies, right? You can use Visual Basic.net, or you can use TickleDK. Lots of things are out there to build standard GUIs quickly and easily, right? Oftentimes these tools are good enough to become the final product. And that's okay. I mean, they are often partly interpreted. So they have a very quick development cycle, as you are used to with interpreted scripting languages. There may be performance issues. I mean, scripting languages have gotten much better in recent years, but you may still be struggling with the occasional problem of an interpreted language, not quite giving you the performance that you might need in a production prototype, in a production environment. Distributing these kinds of prototypes is, yeah, it's a mixed bag, right? If you're lucky, you have a cross-platform toolkit. TickleDK, for example, is cross-platform. Visual Basic, so. But they may require a specific runtime environment that you may need to send along with the prototype itself. So do a little bit of testing ahead of time with the tool that you're intending to pick, whether you can actually send bundled up prototypes to people using, Windows, Mac, Linux, whatever, to run your prototype if it's a desktop app, or that you can somehow get to people in some way even on their mobile phones. That's even harder because app installation is a big hassle and usually requires a full-blown development environment. So that's when sometimes having something online is actually an easier way, because then people can also run it on their mobiles. Now, sometimes you don't want to do a standard GUI. Sometimes you need something a little bit more, out there, something more unusual. And that is when special purpose prototyping tools really start to shine. As an example of a special prototyping tool, I just want to show you one here that is called MaxMSP. MaxMSP is a development environment for multimedia software. What that means is that it is excellent at processing audio and video input and creating audio and an audio-visual output in response. It was originally developed in the 80s to handle MIDI applications. Now, MIDI, if you're not familiar, is a protocol that lets musical instruments talk to each other. It stands for Musical Instruments Digital Interface. And it originally was a very simple serial protocol, some 32 kilobits per second serial link between two synthesizers, for example, so that when some rock band in the 80s pressed a button on one synthesizer on stage, that other synthesizer would also play that sound, because back then, every synthesizer had a different sound and they needed all these to play in sync. So the MIDI quickly became the universal language of having of controlling stage equipment in the broadest sense, lights, of course, all kinds of sound generation devices, but all kinds of sensors have also been sort of made available via MIDI, because it's such a simple interface to implement. And so Max originally started out as this thing that was basically geared straight at musicians who wanted to create crazy MIDI applications. But it quickly was extended to handle processing sampled audio at 44 kilohertz. MIDI doesn't actually send the waveform across when you press a key on one keyboard. It just says, hey, this keyboard just pressed the middle C key with this velocity and with this sound of a trump, the trumpet sound selected. But then the other keyboard would have to take that control information and play its own actual sound in response. So it's not sampled audio that goes across MIDI. Whereas, MaxMSP was then extended soon to also cover things like audio with sampled audio, or even have a real-time feed from a camera come in as video, and somebody maybe juggling balls in there in a stage performance, and then that thing would be able to in real time track the yellow ball that the juggler is using, and in response to the height of the ball, maybe make the sound of a whooshing wave come out of the stage speakers. Right? This is the kind of stuff that MaxMSP excels at. Now, you may not end up building multimedia performance software. I did a bit of that, but it's not your standard fare for projects. But what is interesting is that MaxMSP uses a flow-based paradigm in programming, and that's what I want to show you here real quick. We're going to talk more about this in DIS2 again, but what you can see here is that we're actually connecting little boxes to each other, and these boxes are connected by lines along which events will flow. So what this current one here does is, for example, it simply has a number field up here at the center, the 0, and that 0 feeds into this this Metro 33 thing, and that means that every 33 milliseconds, this thing sends out the value of the number box here at the top out its bottom. So it's like a clock ticking, and the movie object then takes that in and renders a certain movie, and takes the speed of the Metro object to move through the video at a certain rate. So these are simple examples of multimedia processing driven by a flow of data through this pipeline network, and that's a very powerful approach to handle real-time sensor data or audio-visual input and output. So it's very helpful for this specific, type of applications. It also can talk to any kind of sensor or electronic thingamabob that you might, stick into your computer, your laptop, electronics boards or sensor boards, etc. So it's really good for prototyping these kinds of things. I built an interface. I built an exhibit that was also on display in a museum for a couple of years called WorldBeat that used MaxMSP first just to prototype it, and then we discovered that it's powerful enough to actually become the final system. So we built the entire system using this this authoring tool. And just 2 years ago or so, we had a collaboration with an arts group in Belgium who were interested in having dancers influence the sound performance of an orchestra that they were dancing to. And the guys who were developing the code for this, again, used MaxMSP to do that. You can get test licenses for MaxMSP for free, and then you'll have to pay for it. There's also a free player that you can use to share your implementations, your prototypes with users, so they don't need a license. And there's even actually an open source, limited, but open source version for called PD that runs on Linux and related platforms. That doesn't cost anything. Not as powerful and professional, of course. All right, so more about this in designing interactive systems too. It's a very entertaining tool and needs a completely different mindset to think about how you structure your problem when you model it as a flow of data through nodes. So you're very much encouraged to look at flow-based programming as a paradigm because it's an interesting alternative paradigm. And an interesting alternative interface, basically, to create code compared to just writing lines of text. Now, there is, of course, another option to go or another route to go with your user interfaces, and this is the area of user interface builders. Now, UI builders are actually the tools that come with your development environment of the operating system that you are developing for, right? And they are typically tools, graphical usually these days, although they often have a text-based component for storing data and storing settings and parameters and so on. They're usually graphical tools to let you define the UI of a real software application. So at this point, we are moving from the prototype to the actual production code and the interface for that code. These user interface builders are usually part of your IDE, and they have a couple advantages if you end up using them. The first one is, of course, once you start working in these, you can continue working in them, use the assets that you created, the graphics and things for your final system, right? You no longer need to move from your prototype to an actual separate system for your final building. The other advantage, obviously, is if you use these to create your UI prototype, you're getting as real as it can get, right? Because you're using the actual components. So a push button created in the interface builder for example, macOS or Windows, will act like the real push button on Windows or macOS because it is the real push button on Windows and macOS. So, for example, there are often subtle behavioral changes in what happens when I click on the push button, then I drag off the button without releasing. Like, what happens exactly? How does it highlight, etc.? Does it react to hovers? All these things will be just like the real thing because they are the real thing in this case. The other advantage, of course, is vertical functionality can be added very easily, right? Because it is part of the IDE. It usually is just a few clicks and a few lines of code to hook up your user interface to the underlying code. Now, this is one of the key challenges that these tools face as well. How do I make it so that people cannot, it's not just a drawing app that lets me create a bunch of, slides, so to say, or a bunch of graphics or pixels, pixel fields, but how do I make it so that actually when I click on a button, something happens in the code? This link between UI and code is always a struggle. How do I make that convenient for the developer? Because sometimes you want to do this graphically, quickly just hook up your code to your graphical UI. You want to do that with a drag and drop operation maybe. But in other cases, you may want to go in and tweak the settings textually, and this is a tricky thing to do. Now, the disadvantage, of course, of using these things is that you now limit yourself to the Windows system and toolkit that the interface builder supports, right? For example, you can use the interface builder that's part of the Xcode development environment in macOS, but then you are now developing for the Mac with its user interface, and maybe for the you can also then probably release this on iPhones and iPads, but it's not automatically a UI that will look like a Windows app on a Windows computer because it doesn't run there. And similarly in the other direction. So that's a consideration you have to make whether you are developing for a single platform, and if you are, then it makes sense at some point in your prototyping process to move to that built-in IDE to do your final prototyping. Let me show you an example of how this can work, and this is taken from a reasonably recent version of Interface Builder on the Mac. And one thing in here I find quite exciting. So first of all, what you see on the left is all your assets that are part of your project. It's the typical project view, of course. And then what we can see here that we are currently looking at what's called a storyboard for our interface. So storyboard is kind of like what you actually drew earlier on in the paper prototyping stage. The storyboard has each stage of your interaction laid out as a screen, and these screens are connected by transitions, and these transitions happen on certain conditions. As you can see here, there is a main window here, and there's a link from that main window over to this Fahrenheit Celsius box here over on the side, right? We can also see that what we're laying out in this interface builder here is the main menu that has the name of the app, and then a file, edit, format, view, window, and help menu item in the menu bar. And if you were to click on this menu here in the interface builder, it would allow you to actually add menu items to each of these. Some of them might even be prepared for you because they're standard items that every Mac app should have. And so this is helping you to really create the entire UI look and feel of a graphical app on macOS. But that's not exciting because that's been around for like 30 years or so. There were similar tools around even on the Mac in '84 when the first graphical UI toolkit development actually hit the world for third-party developers that had to first start building graphical apps. So that's not new. What's new is that at some point you may want to do more than just tweak the way that your interface looks. You want to define how your interface feels and how it works when people do stuff with it. So look and feel is this dichotomy. Look is what I see, but feel is what the interface does in response to my actions. And to design the feel of the UI, this interface builder, and that's something that by now other systems on Windows and other platforms also start supporting quite nicely, is you actually drag and drop from the UI into your code. So for example, here we can see if the user were to click the convert button in the UI, we want a certain function to be called. And that function is called convert. And the developer of the app is currently, has just basically clicked, option clicked, I think, so that you can, distinguish it from your normal mouse click. He's option clicked on the convert button, and that starts a special kind of dragging operation where you can drag out a blue connector line into the code window on the right-hand side. And by letting that go over the convert function, that means basically, okay, we've now connected that button to that action. So you don't need to futz around with, ID numbers, and this is button number hex, some weird code. And if that hex code button gets clicked, you need to use that same hex code in your code to identify the button. This has always been a struggle. Like, how do I identify objects that the user has, that the developer has defined graphically in the interface builder? How do I identify these in the code? And that's solved by this kind of approach by just giving you a graphical representation that lets you connect the two up. Okay, so again, more about this in Designing Interactive Systems 2. You will have more than you probably could imagine chances to play with a variety of toolkits in there. We basically get you from 0 to hero on a whole bunch of interface toolkits that cover mobile and desktop platforms, and even going beyond the desktop and into hardware prototyping. But I just want to reiterate some of the dangers of software prototypes. If you do these kinds of software prototypes, especially when you move to the final system here, users tend to focus on the design details. They overlook the larger problems. This even goes so far as users becoming afraid to criticize changes or suggest changes in the interface, because your system looks so nice already, right? It looks like it's done, and that's a problem, right? You don't want that. When users think that they can't really, everything has been done already, because that's what it looks like to them. If they see this prototype, they think, oh, this is basically done. I can't tell them to completely change it anymore. Then you lose valuable information. So what you want to do is you want to basically have your interface quality match the maturity of your ideas. If you have just a very rough idea, then you want to communicate that in a rough prototype. And once you have a very polished idea, you want a polished prototype. If you don't do that, and if you go in, and this often happens in industry, that the first thing people prepare, if they're not trained in this, like you are now, if not trained, the first thing they will go in is do a as polished as possible prototype of the interface, if they prototype at all, that looks like the final thing. And then, you show that to the customer or the user that's supposed to use it, and the users get hung up on details. Like, I don't like the orange that you use for that button. And then you have to say, okay, well, please ignore the orange, but they can't ignore the orange. It's impossible because it's there, right? Now, if you just showed them a pencil paper sketch or a digital sketch, but it's on the similar level of roughness, like a pencil and paper version, it's much easier for them to actually not get hung up on details. And the other danger I also explained, managers might think their prototype is done because it looks like it's there, right? And it has to do with the conceptual model that people build of a system, which is basically communicated by the system image. And you're showing people a system image that looks like it's working. We've now seen how you can start with paper, create a very simple, basic prototype of your UI, and how you can then flesh it out a little more with a post-it prototype edition, how you can make it into software. But what we haven't talked about is how do you deal with prototypes that have a particular physical shape, where the hardware aspect of it is also important. So let's look at that now as the next and last sort of section of this class. Hardware prototypes are not always needed. If you're writing an app for the iPhone and Android phones, you don't need a hardware prototype. It's going to run on smartphones, and you can, if you want to do a digital prototype of even screenshot prototype, you can just run it on an actual phone, right, as a series of slides or pictures. But what is when you do need it is whenever you have a system that is hard to imagine or predict its usefulness or how it works by software alone. A little story here. The Palm Pilot, feel free to Google that if you're not aware, if you're not familiar with it, was a PDA, a little personal digital assistant in the 90s that was all the craze, right? It was a little tool that you put in your pocket, and it could actually recognize a particular kind of handwriting, and people would use it to keep their appointments in it and make notes in them and stuff like this. So it was basically the predecessor of the smartphone, where back in the day you had a dumb phone and maybe a thing like this Palm Pilot as your personal digital assistant. this thing was incredibly successful. And the boss of that company that invented the Palm Pilot did something quite unique when they designed this thing. Because at the very beginning, when they started to think about what would our PDA look like, our digital assistant, he had his product engineering team and product design team make a bunch of wooden blocks of different sizes, you know, thin, thicker, smaller, wider, narrower, taller, etc. And then he had his entire team run around with these wooden blocks in their pocket for like a month. And the point was, he said, no matter how smart and cool and amazing we make this upcoming device that we're planning to do, if people don't feel comfortable carrying it around every day, all the time, it's of no use, because then they're going to leave it at their desk when they go to a meeting, or, you know, when they go to the kitchen, you know, to the cafeteria, and that misses the point. They need to always carry it, like a, you know, like a wallet. And so he had people run around with these different blocks, and he said, only once we know what the size is that people feel comfortable carrying around all the time, we can then decide what we can put into it, you know, how much compute power fits into it, what battery technology we can put in, what the display can be like, what kind of apps we can run on it, etc., etc. And this is hardware prototyping. So this is one case where it's important, right? It's impossible to imagine what a good PDA is back in those days if you didn't know what the size was that people would be willing to put up with. Remember, this was in the 90s when people were just getting used to mobile phones, but nobody was carrying around a smartphone every day, right? Nowadays, we're used to that, and we have found a, you know, reasonably convenient size form factor that people are carrying. And they had to find out about this. The second reason why this might be important to do a hardware prototype is if the physical interaction itself is important. Imagine, you know, you are at Microsoft and you are designing the new Microsoft Touch mouse, right? A mouse that has also input, you know, that's also touch sensitive on its surface. Well, you're designing a completely new input device, and it's going to use touch, which is different from just your normal clicking buttons and stuff. You need prototypes. You need to figure out what size, how people's hands should rest on it, etc., to make that thing work. How is that done? Well, as I said, the Palm, you know, Pilot folks used wooden blocks, right? The folks at Microsoft used foam core, which is an excellent material because it can be sanded down with sandpaper very quickly to shape, but it stays, you know, it's reasonably rigid, but it's still easy to shape with tools. Or they might use plastics of sorts. 3D printing, of course, these days is an excellent way to do quick hardware prototyping, right? As is laser cutting. Laser cutting things out of cardboard, for example, is a fantastically fast and cheap way to create prototypes. But styrofoam is also still often used, although it's, you know, handling it is a little bit of an iffy thing. Now, obviously, we're now getting into this area that I know computer scientists are uncomfortable about two things. If it has to do too much with the human side of things, and that's what we're doing in this DIS1 so far, and if it becomes extremely physical, and, you know, if we're talking about tools that can hurt you when they fall on your foot, right? These are things that make us nervous. And now this is what hardware prototyping is. It's stuff that needs physical tools. It is not naturally a skill that you might already have to build these things. And even if you do build it, if you need to change it, it's high effort. It's not just changing a couple lines of codes, right? We're talking about real physical artifacts that need to be maybe reprinted, 3D printed, or remanufactured by hand even to recreate. And it's, of course, an area in which 3D printing and laser cutting and these digital fabrication technologies have made a huge impact, right? It's become so much easier to do physical prototyping now than it was 10 years ago. These are actual examples of the Microsoft Touch mouse that I was just mentioning. They carved dozens of possible variations in this soft, low-density foam that's called a Ren board. And it's easy to sculpt this stuff with tools. And it's one of these things, there is a certain art to designing input devices. It's not a perfect science where you can like just compute or you just use a CAD tool and make the right thing. This needs to be done with your hand on that physical thing to know whether you are on the right track or not. And the differences in these things are subtle, as you can see, but in the end, they make all the difference whether people feel that it's a comfortable device to use or not. Another example, I'm not sure whether you saw this, but before smartwatches took off, there was a very early competitor called the Pebble Watch. It used a display that was actually using an e-ink display that would only consume electricity when it had to be changed. So the watch lasted forever, which was unheard of for a smartwatch. And similarly, these guys, this is not quite so old, right? So this is a 2000s project, the Pebble Watch. They actually 3D printed the prototypes of their Pebble Watch to see what size and shape would be convenient for users while it would still fit all the electronics they had to put into it. By the way, this is a good moment to plug our Fab Lab. Once we're all behind this, really annoying Corona crisis, you will all be welcome to check out the Fab Lab that we have, which has 3D printers and laser cutters right inside our chair in the computer science department building. And they are available to use for free in an open lab day that we do once a week, once we are allowed to receive guests again. So you sign up for a slot there, and then you can use those 3D printers to make your own things. And also, if you take any of our other classes that are a little bit more hands-on, like DIS2 or the Media Computing Project, or even the M3 Multimodal Media Madness undergraduate software project, all of those will make heavy use of the Fab Lab, so you'll get exposure and chance to tinker with those toys and those tools. And it's great fun to 3D print your own designs and laser cut them and create your own PCBs if you're a little bit, on the hardware hacker side, if that heart beats inside you. All right, fablab-aachen.de is the website if you want to check it out. Now, onto those prototypes. Here's an example again that is similar to the one that I also showed under the early paper prototypes, right? It's using, actually, in this case, a 3D shaped, made from cardboard and foam core prototype of a remote, and it was a class project to design a universal remote. And you can see here the prototype is actually using these different insert sheets to show the different screens, but it always does it with the shape in the user's hand, which is very different from clicking on this on the screen. And it also allowed the students to put the buttons that they thought should always be there onto the device as well, and show that would be the complete UI that the user would see. So that's a great use of hardware prototyping, and you can see it's not hard, right? It's hardware, but it's not hard. You just need to cut a bit of foam core and a bit of cardboard, and remember your elementary school crafting classes a bit, and then get crazy with this stuff. Most of the tools that you need are already there, like glue and scissors. But I want to show you an even more amazing hardware prototype. This is taken from one of our first media computing projects that we ran when we had these practical labs for our students. And in that year, I asked the students to design a musical instrument. I love giving out this challenge to create a musical instrument because musical instruments need to be extremely low latency. They need to respond immediately. The mapping is crucial to understand. They need to be easy to start playing, but they need to have a high ceiling of complexity so that it can become really a virtuoso and create awesome things on it. And so it's a great challenge for an interface. Here's an example. One of the, I would say, winning contestants in there was called Bangorama. Now, what these guys built, this is Laszlo playing his prototype, is they said, playing rock guitar is all great with Guitar Hero and so on. We've got lots of games doing that. But what you really want to do is, while you're playing your heavy metal or heavy rock guitar, is you want to do some headbanging, right? So the way that they designed this system is that when you play the guitar, you reach out with your left hand and hold the right keys, hold the right frets down, right, the right strings. And these were done with like aluminum foil that was conductive. But in order to play the actual sound, you had to bang your head. And you can see he's wearing a little cap that has actually a little bit of a, I think it has like a euro cent coin glued to a bit of copper, and that tilts back and forth and hits another copper rail when it makes contact. And that is detected by an Arduino electronic circuit, and that gets fed into a Max MSP patch, the tool that I just talked about a few slides ago, and that then plays, you know, the sound that, you know, the Argita prototype is suggesting. So all of this is wired up to Max MSP. And let me play the video. I think this is better to see than to explain. I may need to change this my share here so that you can see the video and also hear the sound. There we go. Okay. So hopefully that gave you an idea of how that works. I don't need to share any more slides, so I'm going to switch back. I don't need to share any more video. That's what I mean. So this is a great way of showing that this is when you need to hardware prototype, right? That's really bringing this stuff together. And you guys can do this. This has all become very easy to do. These tools to do these advanced electronics have become very easy to access and to get into. Sometimes, however, even hardware prototyping doesn't get us quite where we need to be. And this is the case when you are imagining an interaction that is so different or revolutionary or technically hard to actually build that you can't just whip up a prototype and simulate it in some way. But we have an excellent simulation engine right around us. It's ourselves. So when you have a functionality that you need in a prototype and that is hard to build, think about whether you need to actually implement it or whether you can just fake the responses that the system would give by putting a human in the loop. And by human, I don't mean the user who is the participant who's studying and testing the interface, but I mean the engine driving the prototype can actually have a little person wired in, so to say. And that is what's called the Wizard of Oz prototype. Now, the Wizard of Oz prototype is called Wizard of Oz. Does anybody know why it might be called the Wizard of Oz prototype? Anybody know the story of the Wizard of Oz? This is a culture check, whether you guys are up to snuff in American pop culture. Yeah, Marco, go ahead.
Yeah, I do remember this story, kind of like as a kid. It was about this like some girl and like 3 protagonists or something, but regardless of them, I know that Wizard of Oz was like this person that they were going for. And if I'm not wrong, he was something like known as this wizard who could do a lot of things, but he was just fake or something. I don't know, fake as in just rumors were completely false, or he somehow made people believe with his tricks or something that he's actually a wizard. I'm not sure.
Yeah, actually, very good. Thank you, Marco. The Wizard of Oz is actually a guy who is basically seems to be this huge person, all powerful. But then at some point, Dorothy and her friends discover that actually he is just a tiny guy behind the scenes pulling strings to make that big figurine move around and make all these big effects. And that's exactly why it's called Wizard of Oz as a studying program, because you are faking an interaction. And let me give you a great example of how that works. Imagine it's 1984, you're at IBM and you want to build a text editor that uses voice recognition to enter text and to edit it. Now in 1984, text recognition wasn't great, right? You saw the 1981 video, put that there. That was pretty basic, right? So if you were imagining a fluent speech recognition and voice and text recognition editor, it wasn't there. it was a futuristic idea, and they didn't know how to, but they wanted to find out if I had a text editor, how do I solve that you know is controlled by speaking? How do I do things like deleting a line, right? Obviously the text editor shouldn't just delete a line, it should actually do the command, right? So how do I switch between command mode and entering text mode? Do I need modes like in VI, or how do I do all this? So they had lots of interesting questions on the HCI side, but the technology wasn't there. So what they did is kind of like the setup you see there. They basically had a user who was sitting in front of this he's the guy in the back there, right? He's speaking into a microphone, and he's the user typing stuff in and giving text commands. And then those text commands actually went into a separate room, were being played back to an actual person who both saw what the user was typing and heard what the user was saying in another room. And they would type the correct responses back and maybe simulate basically what the system would do if it perfectly understood the user. And the user being in that other room, well, to him, it felt like the computer had recognized it, right? Because he wasn't aware of that other person in that other room. So that's a great example of using the Wizard of Oz. You basically use a human who basically interprets the input that the user creates and then controls the output accordingly. A couple important things there. First of all, you need to make sure that the human is still following a fixed protocol. Otherwise, you're simulating a human in all his flexible answering capabilities, and you're basically at the knowledge navigator where the system just understands everything, right? So the experimenter needs to know what he is supposed to understand and how he is supposed to react. He cannot react just naturally as a human. Secondly, you can use an actual interface with a real computer and everything, or it could be a cardboard system where it's obvious that the system couldn't really do that. That's fine too. To give you another example, we had folks who were, we had a study in our lab where we were trying to understand how it would feel for people to be tracked indoors and have an audio signal being put on their ears that is basically based on their current location. This was for an exhibit we did for the Aachen town hall. And in order to simulate that indoor tracking, because we didn't have that working at the time, we just had a guy standing in the room watching that other person, and the guy standing in the room would update the user's location in the system based on where he saw that person actually walking in the room. So to the user, it felt, because he was seeing his location was updating live and the effect was on his ears, it felt like the system was working, but it wasn't really. Right? That's another example of a Wizard of Oz. So you can do this a lot, and it's a very handy technique to know about. Another example where we had folks who wanted to basically simulate what it was like if you were standing in front of a big board, an electronic whiteboard, and you were using gestures to interact with the contents on the whiteboard. We ran that study in 2010. It was a master's thesis here at our lab, and it was supposed to use 3 cameras, and we mounted cameras there. So to the user, it felt like he was really being recognized. But back then, gesture recognition wasn't that good. So we basically just had people who were looking at the camera feeds on the next room and then quickly simulated in the interface what was happening, what was supposed to happen in the system. So this is a great way to add simulated and complex vertical functionality. Sometimes you tell the user that there is a wizard running it, but it's actually okay. After 5 minutes with the prototype, they forget about it and they just take the interaction as at face value anyway. Now, we've prototyped in all kinds of ways, and now we're wondering, what are we going to do with our prototype? Well, you've got 2 fundamental options. You can throw it out, or you can continue using it for your next iteration. And that question comes up basically at the end of each DIA cycle iteration again, right? You've used your prototype to hopefully answer some questions that you had about your design, to find bugs in your design, to test it with users, or at least to run some kind of other evaluation with it. We'll talk about evaluation techniques at length in the class later. And if it was quick and cheap to create, like a paper prototype, it's perfectly fine to throw it out. Well, maybe you want to take a couple of snapshots with your camera if you haven't recorded the user studies anyway, which you should. Take a couple pictures of, with a camera to capture your prototype, because later on you may want this for project documentation to explain why you decided to go this way. Or maybe down the line you discover a usability issue, and then you might want to track back and see, let's see, did that already happen in the prototype? Did we just notice that issue, right? But you don't need to continue using it. It has served its purpose if it has answered that question for that iteration. The other option is to just stick with it. You can improve your prototype incrementally and keep fixing things and adding things to it. And it may or it may not even become the final product. And in some cases, especially if you're using a tool like Max MSP for multimedia content, or you're using something like an actual interface builder tool in Visual Studio or in Xcode to create your UI for a standard GUI application, or you're using a high-end animation package and it does everything you need. There may not be a reason to switch to a custom developed app at some point, right? And it can become the final product. The challenge, of course, with this is that you need to carefully look at performance, because most of these prototyping tools and multimedia prototyping tools are not designed to do production level performance. And so test that carefully, but if it works, why not? Why not just hold on to it? So similarly with the hardware prototype, you've made, maybe if you've created your hardware prototype by 3D printing a simple version, then you can maybe use these design files and use them to further improve them and give them to a professional hardware designer to build the final product. That's what we did when we designed, a couple of years ago, we had a project where we built interactive tables that would have little objects on them. And these objects were tracked by the table, right? And these objects would then interact with the table and their position would be recognized by the table, and they would display things around them, etc. The first versions of these we made on the laser cutter. We just cut out a couple of acrylic discs, put some PCB between them. They looked ugly as hell, but they worked, right? And they helped us explore our project. And then we made the second version of this, which was, a nicely designed 3D case by a professional designer, but we 3D printed it in-house with a quick printer to iterate over it and have it quickly and cheaply. And once we were done with that, we actually sent it up to Shapeways, I think, one of these companies that will just print things for you. And the design was done by a professional designer, and it was ready to be injection molded and be mass produced, for example, if we wanted to go that way. And then we got back really nice polished things that you would basically consider that we bought them in a store. They looked so great. So this is, even for a prototype that's hardware based, you can sometimes continue using parts of your design data. All right, let's wrap it up for today. We've learned a couple things. First of all, we've seen that in the DIA cycle, you need lots of prototypes, right? And you need these prototypes at different levels. You want paper prototyping, storyboards, post-its, flipbooks. In the high-level initial rough user interface design phase. We've seen that post-it prototypes already give you a little bit more flexibility and less, pain if you have to do 15 screens that look all the same, or if you just need to change a tiny thing about a screen. You don't need to draw it all from scratch. We've then seen that we can move to software prototypes, or what you might call digital prototypes, meaning we move onto the computer, but we're not coding yet. Don't open up Xcode or Visual Studio just yet. Oftentimes we use tools like animation apps, presentation apps like PowerPoint, or we use custom built prototyping apps like Balsamiq or Adobe XD or Sketch. And these tools, or we use web tools, right? These tools all let us create more advanced prototypes. And what does more advanced mean? Well, the visual fidelity can go up and the interactive fidelity can go up, right? You can start creating non-linear walkthroughs with clickable areas, etc. You can have, you need to think about how you limit your prototype in any way. What functionalities am I not looking at all? Like what features do I not even put in the UI of my prototype? That's vertical limitation. And then horizontal limitation of the features that I do put into my prototype. How deep do I go? do I really need a database running, or can I just live with a fake login screen that always uses the same name? And finally, we saw that hardware prototypes become important if the physical interaction is key, if it's part of the user experience, or if it's so revolutionary that you just can't imagine how it would work with screen prototypes alone. And the last thing is really the Wizard of Oz technique. If you have a really complex functionality these days, for example, advanced AI things become tractable and they become usable in software, but they take quite a bit of training a neural network and then making sure that it works correctly, etc. You can just simulate that. If you think it's it's something you will want to put into your final system, you could simulate that in the Wizard of Oz by just saying, let a human do the recognition task on the image that the user provides. We know that we can keep the prototype or and continue pushing it forward, or at some point maybe move from one format, one medium like paper, for example, onto the digital, right? That's almost always the case that you have that transition. Although I gotta say, if you look at things like Balsamic or Adobe XD or Sketch, these wireframing tools have become really good, and that's one of the big advantages over using PowerPoint or even a Photoshop or something like that. These tools, these wireframing tools, have gotten really good at creating data packages that you can then import into your development process. So you can then use the assets right away in your actual code, right? They understand that this is a bridge that needs to be, it's a gap that needs to be bridged. All right, with that, we're done for today. Thanks everybody for listening. And we will have one more, right? Next week, Ollie?
Yes, we will.
Yeah, okay, thank you. So I'll see you one more time right before Christmas. Until then, have a great rest of the week, and thanks for being around. Bye.
Bye-bye.
This content was provided by RWTH Aachen University.